So hello everyone, let us solve another lead code question, that is silent perimeter. So let us read the problem statement. So you are given a row into column grid representing a map where grid of I, j equal to 1 representing a land and grid of I, j equal to 0 represents water. Now grid cells are connected either horizontally or vertically but not diagonally. Now the grid is completely surrounded by water and there is exactly one island. Now the island doesn't have lakes, meaning the water inside isn't connected to the water around the island. One cell is a square with side length 1 and the grid is rectangular. The width and height doesn't exceed 100 and we need to determine the perimeter of the island. So let us see with the first example what the question says and how we can derive the solution out of it. So let us see this first example. Now this is the matrix that they have given where 0 represents water and 1 represents land. Also they have given one additional information that each particular cell here represents a square and the square length is of 1. Now it is a square of side length equal to 1. Now we need to find the perimeter. So how can we find that? Now I have shaded the land area with green and water area with blue for simplicity and for better understanding. Now in this first example the perimeter is 16. So let us see how they have generated this 16. Now if we start from here, the upper side. So this is the boundary of this matrix. So this will be considered in our parameter. So we will add 1 to our perimeter. If we come across here, it is surrounded by water one side. So again this will also be added in our perimeter by 1. This again is surrounded by water. So again we will add 1 to our answer. So we keep count of the answer. Let's say I am denoting our perimeter with the help of answer. So first we came across this. So 1. Then we came across this. So it will become 2. Then we came across this. So it will become 3. Now we came across this. Now this is again the boundary of the matrix. So we will again increment our perimeter by 1. Now this region is surrounded by water. So we will again increment our perimeter by 1. This side again surrounded by water. So we will increment it. Again if you see this side, it is surrounded by water. So we will again increment our answer. Here it is the boundary. Here it is the boundary. Here also it is the boundary. So we will add 3 to our answer. So it will become 10. Now these two are surrounded by water. This one is also surrounded by water. This one is also surrounded by water. And this one is also surrounded by water. So 1, 2, 3, 4, 5. So 5 and as well as this boundary is also surrounded by water. So we will add 6 to our answer. So it will become 16. So our total perimeter comes out to be 16 and that is what our output is also saying. So how we can say or how we can add our perimeter, how we can add a particular boundary to our perimeter length. So we have seen two observations here. One observation is that, so let me erase this part. So one observation is that if a particular land is surrounded by water, then we will add it to our answer. Or if a particular boundary is not connected or it is the end of the matrix. So if a particular length or a particular side is the boundary of the matrix, then we will add it to our answer. So these are the two conditions where we need to add our answer, add our length to our perimeter. So how we can do is we can use a simple DFS whereby whenever we will start from a particular cell and we keep on going in all 4 directions until we cover each and every point, and we'll keep on adding length to our answer whenever we see these 2 points whenever with these 2 points, we will keep on adding our length to our perimeter. But there is still one more case we have not covered. Let's say I am standing at this point. I go here, I go downwards, I go towards left, and I go towards up. Now when I come here, I again will go to this down, which is already been visited. So I need to keep check of the land which I already visited, so that I don't count it land once again. So what I can do is, wherever I have a 1 present, whenever I visit it, I'll mark that land as -1 to represent that I have already visited this land. So we will use a DFS technique for finding the parameter. So let us write the code now for better understanding. So we will declare a global variable answer, which will store the parameter of our it will store the parameter basically. And what we will do is, we will first create the n cross m, or we will denote the row as n, which will be grid dot size, and we will represent column by m. So int m equal to grid of 0 dot size. So n represents row and m represents column. Now we need to do a DFS traversal, but before doing a DFS traversal, we need to make sure that we are standing at 1. So first we need to find a particular one, then only we can start our DFS traversal, because our perimeter will be always be around the land. So we need to first find the land. And what is land? Land is nothing but value equal to 1. So we need to find first 1. So if grid of I comma j equal to 1, that means we found the land and we need to now start a DFS. Now after DFS traversal, we have completely covered the island and we can break that. Now why we are using a break condition? Because they have given that there is only one island exactly. So if we start from a particular one, then obviously after ending the DFS traversal, we have already covered that particular island that is present in our map. So we can break from here. If there are multiple islands present, then we need to remove this break condition. Now in the end, whatever perimeter we got, we will return that as our answer. Now let us write the DFS function. Now we will first pass the parameters here. Oh, we have already given the grid. So let us write the DFS. So let us give these parameters. Now what is the base case? Now if we find a particular length or particular island connected to a boundary or connected to a water. So what is boundary? If I is less than 0 or I is greater than equal to n, or j is less than 0 or j is greater than equal to m. This is the condition for boundary. Now what is the condition for water? If it is surrounded by water, we can say that a particular land is surrounded by water basically. So that means if grid of I comma j equal to 0, that means we are currently present at water. That means we need to increment our perimeter by 1 and we will return from that, because we have seen that at 2 conditions we need to add a particular land to our perimeter. That is, either we are standing at the boundary or we are surrounded by water. So these are the 2 cases where we need to increment our answer. Or else what we will see, if a particular grid is already been visited, if grid of I comma j equal to -1, that means we don't need to visit this now, we can simply return from there. Or else we need to mark this grid as visited. So we will do it -1, and then we will see all the 4 possible directions where we need to cover. Now what are all these 4 directions? It can be either I plus 1 comma j, it can be it can be either I minus 1 comma j, it can be I comma j plus 1, or it can be I comma j minus 1. And obviously we will pass the grid. Now this was it about the code, so let us try to submit if this works or not. So it is given, so we need to pass n and m also as the parameter. Int n comma int m comma n comma m. So let us see if this works fine or not. So it works fine on sample test case. Let us submit it. So yeah, our code got accepted. So hope you learned from this video. Thank you.